Okay, so this is where we left off with part one. We did the coefficient of variation. We did standard deviation of the sample divided by the sample's average times 100. You got 16.22. Now let's consider the data a population. The sample variance, sigma squared, is the sum of the differences squared, 1345.14, divided by n, not n minus 1 for the sample. This is n. This solution is 64.05. The standard deviation, sigma, is the square root of sigma squared, which is 8.00. The coefficient of variance is sigma over mu times 100, so 8 divided by 50.57 times 100. This coefficient of variation is 15.82. Now here I have the motorcycle miles per gallon listed again so you don't have to flip back to the other page. So the first thing we need to do is rank order it. Remember that there are 21 data elements, so when you rank order them, make sure that you, as you go along, cross them off very carefully. All right, this is where a mistake could easily be made. So once they're rank ordered, we know there's 21. Do 21 divided by 2, which is 10.5, which means the 11th element is our quartile 2. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 53 is quartile 2. Quartile 1 is halfway in between. There are 10 elements, so that means quartile 2 is going to be the average of the 5th and 6th element. So 47 and 48 is 47.5. Same thing, there are 10 elements over here, so we go to the 5th and 6th one. 1, 2, 3, 4, 5, and 6. 5 and 6 are both 54, so quartile 3 is 54. Now the 5 number summary is you add to the quartile 1, 2, and 3, the min and the max. So 22 is our min and 60 is our max. Number 27 is to draw a box and whisker plot. So what we do is we plot our 5 number summary on a number line. So make yourself a number line. Try to make it, kind of scale it properly. What I did is I put 22 min at the far left, I did max at the far right, and then I put 40 in the middle, because 40 is about in the middle of 22 and 60. And then I broke this up until I got enough tick marks to show me where my different data is. Then I put a dot at our min, I put a dot at quartile 1, I put a dot at quartile 2, and I put a dot at quartile 3, and I put a dot at max. Then in our quartiles, I drew a vertical line in each one of these dots, 3 dots, and then I put a top on it and I put a bottom on it. Then from quartile 1, I drew a whisker all the way down to min, and then from quartile 3, I drew a whisker up to 60, the max. And that is our box and whisker plot. You don't have to put these numbers on top. I just did this so you could see what those dots were. All right, the interquartile range is quartile 3 minus quartile 1, so 54 minus 47.5. So our interquartile range, which is IQR, is 6.5. Now, we want to determine, is 22 an outlier? Is it a possible outlier? So what the calculation is going to be quartile 1 minus 1.5, the interquartile range, which is 47.5 minus 1.5 times 6.5. We just calculated that. It's 37.75. So 37.75 is somewhere around here. 22 is way beyond 37.75 So yes, 22 is a possible outlier, and it's because it's more than the 1.5 times IQR. Now let's look at the standard z-scores. All right, the mean heights of students in our class is 56.8 inches, so that's mu. The standard deviation is 3 inches. The shorter person in the class is 41 inches. So we're going to find the z-score of 41 inches. So x minus mu, 41 minus 56.8, which is mu, divided by sigma, which is 3, is a negative 5.27. So this means this person is 5.27 standard deviations below the mean. All right? It's below the mean. So this word should be mean, not median. So because it's more than 2 standard deviations below the mean, not median, mean, it's very unusual. If you're within 1 standard deviation, it's usual. If you're within 2 standard deviations, it's a little unusual. But if you're beyond 2 standard deviations, it's considered very unusual. And as you know, 42 inches is 3'6", so that is short. And that's the second part.